Hey, what's up? This is Madan sir here, and I have come up with the second video from aldehyde, ketones, and carboxylic acid, and this is going to be about the nomenclature part, right? So you basically understand that most of the organic compounds have two types of names. One is common name, and other is iupac name. What important is for the examination point of view is the iupac, but this particular chapter does have a bit of importance when it comes to common name also. So the first thing I'll be telling you is about common names of the aldehyde, ketones, and carboxylic acid. I tell you first, actually aldehydes are named based on the carboxylic acid they are produced from, right? For example, if acetic acid is used to produce an aldehyde, it become acetaldehyde. Acetic acid become acetaldehyde, right? Benzoic acid become benzaldehyde. So the first example I have, like I said earlier, acetic acid get its name as acetaldehyde. Acetaldehyde. Similarly, benzoic acid gives the name benzaldehyde. Now, if you are concerned what's the structure is going to be, so I give you the structure here. This is the acetaldehyde, and there you have your benzaldehyde. This is your benzaldehyde, right? So this is acetaldehyde, this is your benzaldehyde. So they actually produce from benzoic acid, and this one is produced from the acetic acid, which we also remember as ethanoic acid and all, right? I tell you a bit more about is that most of the common name, are obtained from the Greek origin, right? So in the Greek origin, the numbering was a bit different from what we do these days. 1, 2, 3, 4 and all. But they used to number it like alpha, beta, gamma and delta, right? So I remember a structure where they actually had, they actually had something like this: 1, 2, 3, 4. There you have a there you have an aldehyde group, and let's put some bromine here. I'm especially focusing over the NCERT, part. So this is probably one of the example I've seen in NCERT, right? So that's why, I'm taking this. So what they used to do, they used to number the carbon, adjacent to the aldehyde carbon or carbonyl carbon as alpha. This one as beta, and this one as gamma. And if there was more, this was coming out to be delta. So this is the Greek pattern of numbering. So what we can name it here? We can name it beta bromo. It's pentanal. Beta bromo pentanal. Right? So that is also a common naming process. I hope you have get it through. Though they are not much to take you, but Greek used to number the carbon using alpha, beta and gamma, where alpha was the carbon adjacent to the carbonyl carbon, and then there was beta, gamma and delta. If there is some other example, you can name it based on that, right? So let's talk about the ketone. Actually, let's talk about now ketone. Next example I'm talking is like ketones gets their common name from their sources or alkyl group present. Alkyl group present. Alkyl group present. The numbering, also remain. The numbering also remain alpha, beta, gamma, and delta. Right? So this is, now let's take some example. If you remember, a very common acetone, this is what called acetone. Right? Okay. Then if you remember something like this become acetophenone. This is called acetophenone. I'm talking about the common name, right? I'll be then taking IUPAC part, but right now I'm taking acetophenone and acetone based on the common name. So basically, these are some of the examples you can remember, like and now we need to move on to the major part, which is the IUPAC part here, right? So I have to wipe them off. What I will do for making you go through the IUPAC part is I will take the example from NCERT, but in order to copy those questions, I need some time. So I'm going to pause this video right here, and once they are copied over the whiteboard, then I will start doing that and letting you how it's done, right? What I have done here, I have taken some of the question from NCERT, and I will help you with that, and let's see how useful this is going to be. So we have two different types of question here. This is from 12.2, where you have to write the IUPAC name, and this is probably from the 12.3, where you have to draw the structure, right? So first we need to find out what are the IUPAC name of these compounds. So let's do it one by one. So what I will do, the first one we have this CH3, right? So in case you remember, hydrogen is not something you need to pay attention, right? I've told you in earlier, IUPAC nomenclature, videos, where I, definitely and very strictly told you, you don't have to worry about the hydrogens there, right? So concentrate on the carbon. So what I'm doing here, I'm talking about the first one, where first, the second. So what I'm doing here, let me write it first here. CH3, CH3, and you got CH2, and then you have another CH2, and finally you have CHO, right? So like I said earlier, we just need to worry about the carbon. So there is, you have carbon, and there is a carbon. There is, if CH3 or any alkyl group is given inside a bracket, what that means, it's in the brown. So put this as up or down. So this is going to be a carbon, and then I'm placing this carbon right here. There is another carbon coming up, and then there is the last carbon coming up, and this one has this aldehyde functional group, right? Let's count the hydrogen again. 1, 2, 3, 4, 5. So it's 1, 2, 3, 4, 5, and on the second one from left side you have a methyl down here. So I hope you have understand how I converted to this. Now let's do the naming part. If you remember the priority series, which is very, very important for you, you must do that before you even proceed. So that priority series, it was all in your 11th class, first chapter of organic chemistry. And in case you do not, you can check out the previous video where I have exactly described you the priority series and how they can use them, right? So I'm not going to repeat them back here. In case you have doubt, you can go and check it out. So right now what I will do, I'm going to tell you that this aldehyde is a major group, right? There is one functional group and this one is aldehyde. So the numbering of course start with 1, 2, 3, there is you have 4, and this one is your finally 5, right? So numbering has started in this direction. So let's do what the naming. This is called methyl here. So the naming is going to be 4-methyl and pentanal right? Why? Because there are 5 carbon. So this is 4-methyl pentanol. The first one I have done. Let's do the second one. This CH3, CH2, CO, CH3, CH2, CO, then you have a CH, then you have C2H5, right? And then you have CH2, CH2, and finally you have a Cl, right? So let's get through the carbon. The first carbon, the second carbon, the third carbon you have here, but there is a ketone group here. So you need to understand that this oxygen is something like this. Then you have another carbon coming up, but this carbon has an ethyl group. So I will place that ethyl group down here, right? And then there is another carbon here, then this one, and finally you have a chlorine. Let's count the number of carbon. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. Ethyl is up here, right here, and chlorine is on the first one. Now the question is, how are we going to number that? Remember, there is a ketone group, right? There is halo group, there is alkyl group. This is your alkyl. Let me write back. This is your alkyl. Though you know that, but I'm somehow trying to get best of everything. So this is your halo, and this is your ketone. This is your ketone. So ketone is a major group, and these are prefixing groups. So numbering will be definitely started from this side. So this is going to be 1, 2, 3, 4, 5, and 6. This is your 6th position. Let's do the naming part here. This is chloro, and this is ethyl. So alphabetically C comes first. So I will be writing 6 chloro, 4 ethyl, 4 ethyl, and finally hexane 3-one. Hexane 3-one. That's it. Right? So let's take the next part here. Next we have this one, where we have a CH3 here. We have a CH, then there is a double bond CH, and finally CHO. So like I said earlier, concentrate on the carbon. Carbon, there is another carbon, but this carbon has a double bond in between, and then there is the last carbon, 1, 2, 3, 4. 1, 2, 3, and 4. So there is the last carbon you have. This is your aldehyde group. So you need to understand that CHO represents to aldehyde. This represents to aldehyde. I hope you do know. Aldehyde. Right? Now let's do the naming. There are 2 functional groups this time. One is alkene and another is aldehyde. There is one alkene here. Let me write. There is alkene and there is aldehyde. So in case you remember the priority series, aldehyde is more important than alkene as per the priority series. So definitely the number will start from this way. 1, 2, 3, and finally 4. Right? So I'm going to wipe this off. So what I will do, alkene doesn't have a prefix. So this is going to be but. On the second one, but2n. This N represents to the double bond, right? When it's not exactly alkene, then you have to use it as N. Remove the E. So it's but2n 1-ul. 1-ul. Check this out. 1, 2, 3, 4. So there are 2 you have N and 1 you have ul. So but2n 1-ul. Now let's do the next. You have CH3. You have CO. You have CH2, you have CO, and you have finally CH3. So let's concentrate on the carbon. First carbon, then there is second with a double bond O, then there is third, then there is fourth with another double bond O, and finally you have this last carbon. So there are 2 ketone group here. And from this direction what you see, it's 1, 2, 3, 4, and 5. Similarly, this is like 1, 2, 3, 4, and 5. So there is nothing wrong taking any direction. So I will take any direction, and because they both are equal. So let's take this from the left hand side. So this is going to be pent or pentane. It's 2,4-dione. Pentane 2,4-dione. Right? So this is what the next one is. Let's take another one here. Your another one is right here. So you have a CH3 whole thrice, then you have a carbon, then you have another carbon, then you have a carboxylic group. Right? This is what called? This is called a carboxylic group. Carboxylic group. So just concentrate. Now every time you have a bracket in the beginning, concentrate on the next carbon first. So I'm placing this carbon right here, and what that means that these methyl are on this carbon. So you have to place it like that. These three methyl I have placed 1, 2 and 3. And let's take the next carbon. Then you have the last carbon with carboxylic, as carboxylic, sorry. So this is what the structure is. Now this is the, this group is the king of all the functional groups. So this is the most important functional group you can consider when it comes to priority. So this is the boss of all the functional groups. So I will do 1, 2, 3 and finally 4. So there are two methyl here. There are two methyl here. So let me write the name. This is going to be 3,3-dimethyl, 3,3-dimethyl, right? And then butanoic acid. Butanoic acid. That's it. So we have one more that's based on the benzene. So let's wipe this off and go with the last one. I tell you what, every time you try to do nomenclature, don't ever think of that you are going to make some mistakes, because you're going to make tons of mistakes. The first time you do have it's very common to make mistakes. So there's nothing like feeling, that's not happening with me, I'm not able to do that. This one is a first benzene. So you need to understand, let me write this first. So you have OH, C, then you got C6H4, then you got CHO, and you have a P being written here. So what this P represent to para, this P represent to para, and para represent to 1 and 4th position of the benzene. So what that means, there is something to do with the benzene. So this represent to a benzene. So I'm drawing a benzene because I had a benzene. So this is what a benzene is. Now para represent that on first there is one aldehyde here, and on the fourth there is another aldehyde here. On fourth there is another aldehyde here. Sorry, what I'm doing. Right? So this is quite easy now. What you have to do, this become benzene. Another thing is that this is very important. When you have one aldehyde in benzene, it's called benzaldehyde. But when you have more than one aldehyde in benzene, the name changed and they have named it like carbaldehyde. They have given a word called carbaldehyde. So what I will do, benzene, because that is the parent chain. Benzene 1, 4, di for these two, and then carbaldehyde. Carbaldehyde. We have to remember this, and there is something new coming up here. So this carbaldehyde also represent to the two of the aldehyde. Like I said, if there are more than one aldehyde, you can use this carbaldehyde, right? But if there is just one, you can use only benzaldehyde. Right? What looks like here is that I'm done with the naming, IUPAC naming part. So what I have to do, I have to draw the structure, right? Okay. So right now I'm going to do the structure part. The first one we have 3-methyl-butanol. 3-methyl-butanol. Now concentrate, this is something different you are trying. Okay, the first thing you need to concentrate on in the end of the name. The first thing is that al represent to an aldehyde. So this is the aldehyde group. Butane represent to 4 carbon. Butane represent to 4 carbon. And this methyl represent to CH3. And this represent its position. This represent its position. So based on that, now I will do that. So first thing you need to do, draw 4 carbon in a chain. 1, 2, 3, 4. And since you do know that the aldehyde always comes on the terminal. So this is your aldehyde. Right? And on the third position you have methyl. So it's going to be, this is going to be 1 because this is the priority, very important functional group. So 1, 2 and 3. So this is what the methyl group looks like. What you have to do, you have to place hydrogen everywhere. You have to place hydrogen everywhere, which I'm not going to do. I'm going to do it just once here so that you understand that this is also very important. Another thing is that, very important, I make this mistake. In case you, I hope you have understand it. Let me say you something. In case you do not place this hydrogen, if you do not place this hydrogen, they might, confuse like this one is a carbon also that represent a methyl group. So you better put hydrogen, right? Don't do it like I'm doing. Right? I'm like addicted, so I do not concentrate on hydrogen, but you must do that. Do not leave the hydrogen, unoccupied there. So you have to place there. So the first one I've done, let's do the second. The second one we have is para nitro propiophenol, right? This is your para nitro propiophenol. Now, the first thing, phenol represent to benzene. This represent to benzene. Para represent to 1 and 4. Nitro represent to NO2. And propio represent to 3 carbon. Because prop you do know. So what we have to do? We have to place first a benzene. Benzene. So this is your benzene. Now, place anywhere you want this nitrogen, right? Like I'm placing it right here. Nitro. Now, since it was a para position, there is lack of space, so I'm placing it NO2 here. So this was para. So this is 1, 2, 3, 4. 1, 2, 3, 4. So that means that propio is going to be somewhere there. Propio, but there is a phenol. This one represent ketone. This one represent to ketone. So what I will do? Ketone always comes in the center, right? Ketone doesn't come on this one, because if you place this oxygen right here, this become aldehyde. So this is para nitro propiophenol. Now let's do the next one. What next we have is para methyl benzaldehyde. So it's para methyl benzaldehyde. Again, there is benzene, right? Para. This represent to 1, 4. This represent to methyl. And this represent to aldehyde. This represent to benzene, C6H6. You have to isolate each and every small part of the nomenclature you are doing, in case you are trying with difficulty, right? So this is how you begin. So let's, let's do this here. So this was your benzene. So I'm doing, first I'm placing a benzene here. And then it's para. So what I will do, I will place a methyl here. You can place anywhere. You can start anywhere, 1, 2, 3, 4, anywhere, or 1, 2, 3, 4. So 1, 2, 3, 4. And that, what that means, the aldehyde is on the 4th position. So aldehyde is on the, 1 position. This is your 1 and this is your 4, right? Because this is the major group, so that's why numbering start from this position. So it's para methyl benzaldehyde. I hope you have understand. Now let's do the next one. 4-methyl pent 3N 2-one. Probably this is. Okay. So again concentrate. This is your methyl here. This is your methyl. Pent, 5 carbon. Right? N, double bond. On, ketone group. Ketone. Let me write it ketone. This is your ketone. What you have to do? Draw first 5 carbon. 1, 2, 3, 4, 5. Now place on the, first you need to understand that the ketone is major. So on the second one, either this one or this one is going to be a ketone here. So this is your 2-one. This is done. Now on the third you have a double bond. So 1, 2, 3 you have a double bond here. And then you have on the fourth 1, 2, 3, 4 you have a methyl. That's it. Now let's do the next one, which is para dihydroxybenzophenol. So it's let me write the name first. It's PP hydroxy benzophenol, right? Now, there is something you have to concentrate because this is a little bit different here, right? So, what you have to do, the first thing is that there is a benzene, there is a ketone, there is benzene, sorry, there is a benzene, there is a ketone, there are two hydroxy because this is 2 and then there are 2 OH, right? So what I will do, I will make a first thing. Benzophenone is something you are doing it for the first time. So let me draw the benzophenone first. So this is, a benzene, and this is another benzene I am drawing. This is another benzene. So what happened here, when you place a ketone group in between, this is called benzophenone. Now there are 2 hydroxy group on para. So this is 1, 2, 3, 4. So there is one OH here, and then 1, 2, 3, 4. So there is another OH here. So this is how para dihydroxy benzophenone can be done. Now let's do the last one. Concentrate. Hex 2N 4-ioic acid. Let's work this out. You have 6 carbon. You have an N double bond. You have an ion. You have a triple bond. You have an oic acid, COOH. That's it. So let's place 6 carbon together. 1, 2, 3, 4, 5, and 6. Place, this is like I said earlier, carboxylic is the king of all the functional group. So it's always occupy the first position. So let's place it either here or here, anywhere you want. So double bond and OH. This is something. This is done. Right? Now, this is on the second one, you have a double bond. So 1, 2, you have a double bond here. Done. You have a triple bond on the fourth. 1, 2, 3, 4, you have a triple bond here. Done. And hex, you have already taken. So this is what you know. Now, then you have to remember that there are some hydrogen you need to place, right? Right here and right here. So this is what you can do with your nomenclature part. Right, so with that I must wind this video right here because this has already gone way beyond the 30-40 minutes of time. I would say thanks for watching. Do let me know where I helped you or it was absolutely not helpful to you. I would say thanks for watching, thanks for your patience, and giving me your feedback is something I'm really expecting you to do. So I would say thanks.